Okay, let's take a look at checking math boxes 5.6, and that would be on page 168. Question number 1. Kenny had 3/8 bags of marbles. Marla had 1 4/8 bags of marbles, and Karen had 1 1/8 bags of marbles. How many bags of marbles did they have in all? Lots of different ways we could attack this problem. I'm going to separate out the whole numbers and the fractions to see if that makes it easier for us. So each one had a whole number of 1. 1 plus 1 plus 1 gives us 3 in our whole number column. And then we have 3/8 as a fraction plus 4/8 as a fraction plus 1/8. And if I add that all up, 3 plus 4 plus 1 gives me 8 as my numerator, and my denominator, which names the pieces, tells me that they're all eighths, so that gives me 8/8, and I know that 8/8 is a whole. So I can now take that and add that together with the other wholes that I have, so 3 plus 1 equals 4, and the answer is 4 bags of marbles. Question number 2 says draw and label ray AT. Now we should remember that rays have a point on one end and they continue out, keep going in forever, so we're going to give them an arrow on the other end and we connect that with a ray of sunlight. So I'm not going to use a straight edge for this. I'm just going to draw a point and try and get a straight line going here, and there's my ray, but I do need to label it RT, so I need to have 2 points on my ray, and I will label one R and label one T, and that defines the line that the ray is on. And here I get draw and label line segment LB, so it's a segment of a line, it's a part of a line. So it's not going to be like a ray in that it continues and goes on and on. It just has a definite beginning and a definite end, and those are labeled L and B. And again, those could be switched around, B and L, as long as I have those 2 points on my line. For question number 3, let's read that first. Fred purchased items at 3 different stores. For his home remodeling project at store A, he spent $587. At store B, he spent $391, and at store C, he spent $1,008. How much money did Fred have left if he started with $2,564? So looking at this in context, he spent 3 different amounts, and I'm going to have to total those up to get my answer for the total that he spent. But the question was, how much did he have left if he started with $2,564? So I'm going to take that total and subtract it from 2,564. Okay, so store A, 587, B, 391, C, 1,008, and let's add all that together. There's 816, carry 1. There's 9 plus 9 is 18, carry 1. There's 6 plus 3 is 9, nothing to carry. So he spent $1,986. Now I need to subtract that from $2,564. Okay, I'm going to have to do some regrouping here. I'm not going to take 6 away from 4, so I'm going to make this a 5, bring 10 over, make that a 14. Now 14 minus 6 is 8. I'm not going to subtract 8 from 5, so I'm going to go over here and make this a 4, make that a 15. 15 minus 8 is 7. I'm not going to subtract 9 from 4, so I'm going to make that a 1 and that a 14. 14 minus 9 is 5. 1 minus 1 is 0. So there's my final answer, $578. Okay, question number 4. they're asking us to put a check next to all the fraction pairs that are equivalent to 3/4. So it's important for us to understand that in order for us to be able to put a check in the box, both fractions have to be equal to 3/4. And so if we're doing this and we see one that's not, even though the other one may be, we can immediately eliminate that pair. So let's begin looking at these. Okay, number one, 4/8. 4/8 is 1/2. So even if this one were equal to 3/4, and it's not, I know that this pair does not work. So I'm not going to put a check in that box. And I look at these two, and I see 6/10. That can be reduced to 3/5, which is not equal to 3/4. So again, already I can eliminate this pair. 6/8. Well, if I took 3/4 and I multiplied it times 2/2, okay, which there's my 1, there's my whole. I'm multiplying it just by 1, so I get an equivalent fraction. I get 6/8. So here I have an equivalent fraction, so now I need to check the second one. Is there something I can multiply 3/4 by that would be a whole number, the whole number 1, and come up with 9/12? And I'm going to multiply 3/4 times 3/3, and I get 9/12. So this time again, my 1 here was 2/2, my 1 here is 3/3. I get an equivalent fraction, so I'm going to place a check mark there. And the next one, let's try 12/16. Well, I know that 3 times 4 is 12. So if I would have to multiply this by 4/4 in order to find the equivalent fraction. So I get 12/16, and yes, that works. So does the second one work? Well, again, shouldn't really have to do the math here, okay, because 1/4 is 25 cents, 2/4 is 50 cents, 3/4 is 75 cents, and 75 cents out of $1 is exactly what I just said, 3/4. Okay, if I did want to multiply it out, I could do 3/4 times 25/25, and then 3 times 25, or 3/4, 75 cents, 4/4, $1. So both of those are equal to 3/4. Number 5, it says to add, but I have a problem here. They don't have common denominators, and that's not something we've talked about yet. So this is something they're wanting us to look ahead to and see if we can figure it out. And they do give us this piece of information right here. Okay, if we wanted to look for help, we could go get one of those student reference books and look on page 168 and 167, excuse me, 166 and 167 if we wanted to see how we might be able to do this. So there's a reference for you to be able to do that. Okay, I'm just going to go ahead and show you what can be done. Okay, and what we need is a common denominator. So we're looking for an equivalent fraction to 3/10 that has 100 as a denominator, or we could work backwards too, but I'm going to work forwards because I think that's the way we usually do it. And if I just multiply both sides by 10, the top by 10, the bottom by 10, now I have hundredths. So 3/10 is 30 hundredths, and 30 hundredths, oops, plus 50 hundredths. My denominator stays the same. I just add the top part, and I get 80 out of 100. Same thing down here. Okay, I have 5/10, but that is also 50 hundredths, plus 35 hundredths equals 85 hundredths. Next one, well, the first number this time is in hundredths, and the second one isn't. 4/10, but again, multiply the top and the bottom by 0, or by 10, adding a 0. Okay, and I get 43 hundredths. And the last one, the first number needs to be put into hundredths because the second one is. And I can do that by multiplying the top by 10 and the bottom by 10, plus 6 hundredths equals 36 hundredths. And the next one is simply a comparison using greater than, less than, or equal to. And so again, we need to think of this as a place value situation, and the larger place value will determine if the number is greater than or less than. For instance, in the first one, everything's the same until you get to the hundredths place, and both numbers the hundredths place. And so we'll use the hundredths place to determine which number is larger, and 5 is larger than 3, so this one is greater. In the second number, we go to the tenths place because they both have zeros and the ones. So we go to the tenths place, which is the next highest place value. Okay, and 6 is greater than 3. In the next number, 7 in the tens place, 0 in the ones place, 0 in the tenths place, so we go to the hundredths place, and 9 is greater than 5. And the next number, 0 in the ones place, 4 in the tenths place, okay, and here we have nothing, and here we have nothing. So those two numbers are equal.